In this video, we continue our discussion on Chapter 7, where last time we began our examination of business cycles. In this video, we will start our development of the ADAS model, beginning with the long-run aggregate supply curve by considering the ADAS model, the long-run aggregate supply curve, labor force increases, productivity increases, then concluding with a summary on the long-run aggregate supply curve. With all this in mind, beginning with our preliminaries, last time we defined, classified, and uncovered features about business cycles, where we defined business cycles as short-run fluctuations in real GDP. We classified business cycles in terms of four phases, where the four phases were peaks, troughs, recoveries, and contractions. And in terms of features, we determined that if an economy was in a full employment state and was recovering to a peak, it would likely experience inflation problems. Whereas if an economy was in a full employment state and was contracting to a trough, it would likely suffer from unemployment problems. So, with these observations in mind, the primary way that we will demonstrate them, as well as tell our overall story for business cycles, is through the ADAS model, which is a graphical representation of the aggregate product market of an economy. Given that it's the aggregate product market, it will consider all goods and services being exchanged. So in terms of quantity levels, we'll be dealing with real GDP, and in terms of prices, we'll be dealing with the price level of an economy. As such, what this model does is it determines the real GDP level and price level for an economy, and will allow us to gain some insights in terms of the unemployment rate and inflation rate as a result. And the way that this is overall accomplished is that it considers potential real GDP, aggregate selling behavior, and aggregate buying behavior, in which potential real GDP will be represented with the vertical long-run aggregate supply curve, aggregate selling behavior will be represented by the upward sloping short-run aggregate supply curve, and aggregate buying behavior will be represented by the downward sloping aggregate demand curve, where these components are what we seek to develop. And additionally, in terms of this model, although it determines the real GDP and price level for an economy, which is very useful, and grants us insight on the unemployment rate and inflation rate, further explanatory capabilities of this model is that it will allow us to see an economy at a full employment state move to a non-full employment state, and an economy at a non-full employment state move back to a full employment state. So overall, consider the entire narrative of a business cycle. So then, with this model in mind, in terms of its explanatory capabilities, let us now begin developing its components, where we will start with the long-run aggregate supply curve, where we mentioned that the long-run aggregate supply curve represents potential real GDP, and this will be true for an economy in a given time period holding all else equal, where below we have a graphical representation of our ADAS model, in which the price level is on the vertical axis, real GDP is on the horizontal axis, and in terms of the long-run aggregate supply curve, we see that we have a vertical curve in black, intersecting the horizontal axis at a real GDP level, capital Y star, where here, capital Y star is going to represent potential real GDP. Now, the reason why the long-run aggregate supply curve is vertical is recall that in our discussion of growth, potential real GDP only depends on the labor force and productivity of an economy. That is to say that potential real GDP is independent of the price level. Now, with this intuition in mind, the way that we can convey this graphically is by relating our aggregate production function to the ADAS model. So let us derive this result then. So beginning with our aggregate production function, we have seen that real GDP is on the vertical axis, quantity of labor is on the horizontal axis, and in terms of the production function of an economy, it is upward sloping and concave down, where it's upward sloping indicating that more is better in terms of labor, and it is concave down to indicate diminishing marginal returns, in that more is better, but not as good as the prior unit. Now, in terms of how aggregate production conveys potential real GDP, recall that potential real GDP is the real GDP level that an economy can produce given full utilization of its production resources. So here with the aggregate production function, here we're explicitly concerned with labor, and we're assuming that technology and the remaining factors of production are fixed. So here what this would mean would be full utilization of the labor force of an economy, where here we're assuming that full employment labor for this economy would be capital N star, where moving up on our production function at point A, This would mean that this economy is fully utilizing its labor force as well as its other production resources in order to produce the potential real GDP level Y star. And in terms of the discussion, as before, here we're concerned with identifying potential real GDP, not if this economy is actually producing potential real GDP at the moment or not. So then, with potential real GDP determined, moving on, what we'd like to do is to represent this in our ADAS model, where in our ADAS model, we saw that real GDP was on the horizontal axis, where here in our aggregate production function, real GDP is on the vertical axis. So what we're going to do is we're going to move horizontally, and we're going to introduce this new graph in which real GDP is on the vertical axis and real GDP is on the horizontal axis, and we have this 45-degree line which represents real GDP, and all this is to do is to shift real GDP on the vertical axis to the horizontal axis so that we can convey it in our ADAS model. So with this in mind, once again moving horizontal from our aggregate production function at the real GDP level of capital Y star for potential real GDP, we intersect our 45-degree line at point A, still corresponding to Y star, where if we were to move downward to our horizontal axis, we would still be at the potential real GDP level Y star. Now, moving vertically, we intersect the horizontal axis of our ADAS model with real GDP as needed, where this then generates our vertical curve representing potential real GDP via our long-run aggregate supply curve, where once again this is vertical, given that in terms of potential real GDP determined in our aggregate production function, it does not concern itself with the price level, instead with the labor force of an economy and the productivity of that labor force. So then with our vertical intuition in place, as well as our graphical derivation of the long-run aggregate supply curve, now what we'd like to do is to examine how changes in potential real GDP will correspond to changes in the long-run aggregate supply curve. In other words, we would like to look at how changes in the labor force and how changes in the productivity of the labor force of an economy will alter long-run aggregate supply. With this in mind, we'll begin with labor force increases. And the way that we'll convey this is by beginning in the aggregate production function, then moving our way through the ADAS model. So beginning with our aggregate production function, we once again have real GDP on the vertical axis, labor on the horizontal axis. We saw that previously for this economy, full employment labor for this economy was at the level capital N star. We're moving up on a production function. This meant point A, and full utilization of its other resources meant production of potential real GDP Y star, where this economy could or could not be producing at this level, but at the moment we're just concerned with identifying potential real GDP. Now, in terms of there's a labor force increase, this would either be through immigration or through young people entering the workforce, where in either case, if some combination happened, with a greater pool of potential labor resources, then more could be produced in terms of total output due to more is better. And how we'd represent this is rightward movement along labor from N star to N1 star to indicate this increase in the labor force of the economy. We're moving up on a production function. We would be at point B, where at point B we see that full utilization of other production resources along with the increased labor force would mean that real GDP produced could be Y1 star, where Y1 star is our new potential real GDP for this economy. Now to convey this in terms of long-run aggregate supply, we move horizontally to our 45-degree line, where in terms of our vertical axis, we see that Y1 star is strictly greater than Y star, indicating an increased potential real GDP. Intersecting our 45-degree line at point B and moving down on our horizontal axis, we see that once again, Y1 star is still greater than Y star in terms of potential real GDP. Then finally moving upwards, intersecting our horizontal axis on our ADAS model at real GDP, we see at Y1 star, we generate a new long-run aggregate supply curve in purple designated as long-run aggregate supply 1, where there has been a rightward shift in the long-run aggregate supply curve due to this increase in potential real GDP from Y star to Y1 star. So then overall what we have then is if the labor force of an economy increases, we know that this means rightward movement along a production function, where this rightward movement along a production function means that there's an increase of potential real GDP, where with an increase in potential real GDP, this then meant a rightward shift in the long-run aggregate supply curve. So now repeating this exercise, but considering productivity, let us see what we find. Well, in terms of productivity, holding the labor force of an economy constant, a few things can happen. This labor force can become more skilled through on-the-job training or through education. Another factor of production, such as capital, could increase, or technological innovation could occur, where in either case, what occurs is that the same amount of labor resources that are available to the economy will find it easier to produce more goods and services, which will mean an increase in potential real GDP, where we will see that this will also mean a rightward shift in long-run aggregate supply. So to convey this, let us start with our aggregate production function once again. Well, in terms of productivity increases, in our aggregate production function, we're only examining explicitly labor and real GDP that can be produced, given that our other factors of production as well as technology are fixed. So say in this case that the labor force of the economy remains fixed and they gain more on-the-job training or gain more education. In either case, at all utilization rates in terms of the labor force, more goods and services can be produced. So what this will mean will be an upward shift in the production function from production function in red to production function 1 in purple, where if this economy were to fully utilize its labor force, where once again this would be full employment labor N star, moving up under production function, we would go from point A on production function in red to point B in production function 1 on purple, where moving horizontally, this means that if other production resources were fully utilized, this economy could produce Y1 star in terms of real GDP, which would now be our new level of potential real GDP in the economy, which we see is strictly greater than Y star. Now, to move this to our ADES model, we move horizontally to our 45-degree line, where we see on the vertical axis Y1 star is greater than Y star, as we saw before. Intersecting our 45-degree line at point B and moving downwards, we now see still that on the horizontal axis, Y1 star is to the right of Y star, indicating that it is greater than it. And then lastly, in terms of moving upwards to our ADES model, we intersect the horizontal axis at Y1 star, where we generate a new long-run aggregate supply curve in purple, designated with long-run aggregate supply 1, where once again we see that Y1 star is greater than Y star. So then what we have then is if there's a productivity increase in the economy, what this will mean is an upward shift in the production function, where with full utilization of labor, this means potential real GDP will increase. But once again, with an increase in potential real GDP, this will then mean a rightward shift in the long-run aggregate supply curve. So then, summarizing what we have found out about the long-run aggregate supply curve, in the ADES model, it represents potential real GDP, and it is vertical given that it is independent of the price level, and it will shift due to changes in the labor force of an economy or due to changes in labor productivity of the economy, where if there's an increase in either of these determinants, this will correspond to a rightward shift in the long-run aggregate supply curve due to an increase in potential real GDP. Alternatively, if there was a decrease, which seems unlikely given what we've seen in our US data set, what we would have would be a decrease in potential real GDP and a leftward shift of the long-run aggregate supply curve. So with all this in mind, next time we'll pick up by developing the short-run aggregate supply curve.